So next, we're going to be talking about scaling our EC2 infrastructure. And while we have already introduced this topic, we're going to be taking a bit of a deeper dive. So let's quickly revisit the concepts that we have already covered. We talked about different ways that you can scale on EC2, the first being vertical scaling or scale up. And that means if we've reached the end of the demand that our server can support, we can simply make it a bigger server, make it to have more resources by having a larger instance type. But then we also have horizontal scaling, and this is where we scale out. So instead of making our server bigger or making our servers bigger, we're going to actually just make more servers, and then we'll be able to route users to whichever server has the lowest demand. This is horizontal scaling. And we talked about the fact that in the cloud, horizontal scaling is a much more sustainable approach than vertical scaling. And this is baked into EC2 with a couple of specific services. So first of all, we have the concept of an auto-scaling group. And this allows us to have a group of EC2 instances that work together with shared rules for scaling and management. And then we have a concept that we have already introduced, which is an elastic load balancer, which allows us to distribute traffic across multiple targets. So let's learn more about the new concept that we've introduced here, auto-scaling groups. So within EC2 auto-scaling groups, first of all, there is a launch template that defines the instance configuration for the group. So if you know, for example, that you're going to want to have a Windows 2019 server and it needs to be a certain instance type, and you know that it's going to need to have the certain security group associated with it, you can define all of those settings within the launch template. And then every instance that gets launched within the auto-scaling group will have those characteristics. Now you also can define the minimum, maximum, and desired number of instances within the auto-scaling group. So let's say, for example, that we have a web application that we're running on EC2, and we know that we need to have at least 2 servers running, so 2 can be our minimum, and let's say that our maximum here is 6, but we want to have 4 as our desired number. So just on a normal day at a normal point in time, it needs to have 4 servers up and running. So you can define those, and the auto-scaling group will manage the group of instances to that. Now it performs health checks on each instance. So you can define how it knows if an instance is healthy or not. If you have a web application, for example, that's running on this EC2 server, you can choose to give the specific URL that it should check against that server to make sure that it's working properly. If it returns a proper status code, it assumes the instance is healthy. But if it doesn't, then it would assume the instance is unhealthy and it would take action. Now, an auto-scaling group exists within one or more availability zones in a single region. And you usually have it span multiple availability zones because this adds a level of fault tolerance that even if you had a complete availability zone go down, your auto-scaling group could still be up and running. Now, this can work with on-demand and spot instances. Now, let's actually look at this in action. So first, we have a region. And in this case, this will be US East 1. And inside of our region, we have configured a VPC with an internet gateway. And this VPC will house our custom application. And we have supported that across 2 different availability zones, A and B. And we created our auto-scaling group, and it exists within both availability zones. And we chose to have a desired capacity here of 2. So it's going to try to keep it balanced between the different availability zones, so it will launch 1 instance in availability zone A and 1 instance in availability zone B. Now we want to have users be able to be routed to a server, the server that has the most room to handle their request. And so we're going to have a specific type of ELB called an application load balancer that's going to be between our users and the specific servers that they're going to be accessing. Now it knows how to work effectively with the auto-scaling group. So it knows what instances are healthy and which ones are not. So in the beginning, all of these instances are healthy, so the application load balancer can route user traffic to either of the servers. However, let's say that something changes, and the server that we have in availability zone A is no longer healthy. Well, the auto-scaling group will note that, it will let the application load balancer know that, and it will stop sending traffic to that particular server, while the auto-scaling group terminates that server and then goes in and actually starts a new server. Once that startup process is complete, it can communicate with the application load balancer and let it know that it is now safe to send traffic back to availability zone A. Now let's talk about another concept for how we scale. And that has to do with the AWS Secrets Manager. So you need a way, when you're scaling out to multiple servers, to securely integrate things like credentials and API keys and tokens and really any other secret content in a way that can't be compromised. This wouldn't need to be with our startup code, for example, on the server. It wouldn't need to be with our custom code that might be sitting in a repository somewhere. There needs to be a safe way that we store this information. For example, if our web application were going to work with RDS as a database, it would need to have a secure way to get the credentials for that database. And Secrets Manager integrates natively with RDS, DocumentDB, and Redshift. And it can auto-rotate credentials with these integrated services. So you wouldn't want to keep the same username and password for RDS for 3 years, for example. You do need to change it periodically just to make sure that there are no vulnerabilities. And so this is included by default within Secrets Manager that you can configure this auto-rotation. And another benefit is that it does enable you to have fine-grained access control to those secrets. So you know exactly what servers and what applications have access to which secret values that are stored within the Secrets Manager.